Hello and welcome to the first class in this term. We'll start up this new term with a topic, inequality. Okay, and our focus today will be on linear inequality, the introductory part of it, inequality with reversing symbols and number line. But before that, let us refresh our memory with what we did in our previous term. Welcome back. Let us quickly go to the meaning of inequality. Okay, the word inequality means an algebraic sentence which contains an equality sign. I said that an inequality is an algebraic sentence which contains an inequality sign, and this inequality sign includes what we call less than, which is this sign here. We have less than or equal to, less than or equal to. Then we have this sign here which we call greater than. Then we'll have the other sign, the greater than with a slash under it, which is greater than or equal to. Greater than or equal to. These are the four signs we'll be using in what? Inequality, and we call them what? Inequality signs. Inequality signs. Okay, let us look at the problems of inequality. When we have a problem like let's say we have 3m plus 3 is greater than 9, and we are asked to solve. All we have to do here is to collect like terms, and whenever a number crosses the inequality sign, the number changes, just like the equality sign. When a number crosses the equality sign, the number changes. Okay, so we have 3m to be greater than 9. 3 crossing over becomes minus 3. Therefore, our 3m is greater than what? 9 minus 3 will give us what? 6. Is that correct? Then our m is greater than 6 divided by 3. Our m is greater than what? 2. That's just how the inequality works. Okay, let us look at how to reverse signs in inequality. Okay, some signs change in inequality when some certain conditions are met. So therefore, let us look at these conditions. Okay, when the same number is added or subtracted from both sides of the inequality, then the sign remains the same. The sign remains what? The same. It doesn't change. Okay, that's the first condition. Whenever the same number is added or subtracted. Okay, so we talk of what? Addition, and then what? Subtraction. Addition and subtraction. When we have an addition and subtraction, then we say that the sign does not what? Does not change. Addition and subtraction does not affect what? The sign of inequality. Okay, we have also that the sign does not change when a positive number, when a positive number multiplies or divides an inequality. Multiplies or divides both sides of an inequality. Okay, when a positive number multiplies or divides both sides of an inequality, the sign does not change. Okay, but there's a condition that changes the sign. There's a condition that reverses what? The sign, and that's why we call it what? Reverse in what? Signs. Okay, so when a negative number multiplies or divides an inequality, then the sign does what? Changes. The sign changes. If it is less than, it changes to greater than. Then if it is greater than, it changes to less than. If it is less than or equal to, it changes to greater than or equal to. If it is greater than or equal to, it changes to less than or what? Equal to. Whenever a negative number multiplies or divides both sides of what? An inequality. Do we understand now? So these are the conditions. I said earlier that when the same number is added or subtracted, the sign does not change. When a positive number multiplies or divides, the sign does not change still. But when a negative number multiplies or divides both sides of an inequality, then the sign changes. Okay, so let us take some examples to illustrate this. Assuming we have the question here on the screen, we have let's say 5 into 3 minus 2x plus 4 is less than or equal to, let's say, 5 minus 3x, and we are asked to solve this. The first thing we need to do is to open this bracket. 5 times 3 will give us what? 15. 5 times minus 2x will give us minus what? 10x. Is that correct? Plus 4 is less than or equal to 5 minus 3x. Is that correct? Okay. If we collect like terms, what do we have? Collecting like terms, we have minus 10x. To this minus 3 crossing over becomes plus 3x. Is less than or equal to, we have 5 here. This 15 crossing becomes minus 15. This 4 crossing becomes minus what? 4. So we have minus 10x plus 3x to give us minus 7x. Is less than or equal to 5 minus 15 will give us minus 10. Then minus 4 will give us what? Minus 14. Is that correct? Now what do we do here? We divide both sides by what? By minus 7. Divide both sides by minus 7. When we divide both sides by minus 7, this sign will do what? Will change. So we have minus 7x over minus 7, and this will become greater than or equal to. Do we understand now? And then we'll have minus 14 over minus 7. Do we understand? So this minus 7 will cancel this, and then we'll have that x is greater than or equal to minus 14 divided by minus 7 will give us what? 2. And that becomes the answer. Okay? So that is how it changes. Let's take one more example. Assuming we are given x plus 3 over 2x, then to be greater than or equal to 5 over 3x minus 7 over 6. Okay, what do we do? Let us start. We'll have all these to be in fraction. We have 3 over 2, we have 3 here, we have what? 6. So the first thing we need to do is to multiply each term by the LCM of 2, 3, and 6. What's the LCM of 2, 3, and 6? Okay, let's find out. I don't want to do guessing here, so let me just teach us how to do that. 2 into this, we have 1. We have 3. 2 cannot go into 3. 2 into 6 will give us what? 3. So 3 into this will give us what? 1, 1, 1. 2 times 3 will give us 6. So that means that the what? The LCM of 2, 3, and 6 is equal to what? 6. How do we get 6? 2 times 3, 6. Okay, so that's the LCM. So we multiply through by what? By 6. And that will give us 6 times x plus 6 times 3 over 2 x is greater than or equal to we have 6 times 5 over 3 x. Then we have minus 7 over 6 times what? Times 6. Okay, this will give us 6x, and 6 times 3 will give us 18 divided by 2. We have what? We have 9x. So plus 9x is greater than or equal to 6 times 5 is 30. 30 divided by 3 will give us what? 10x. Is that correct? So have 10x. Then this 6 will eliminate this 6 to give us what? Minus 7. Then we collect like terms. If we collect like terms, we then have 6x plus 9x minus 10x is greater than or equal to minus 7, and this is 6 plus 9 is 15. 15x minus 10x will give us 5x to be greater than or equal to minus 7. Okay, so we divide both sides by what? By 5. We then have this over 5 and minus 7 over 5, and this 5 will eliminate this 5. X is then greater than or equal to what? Minus 7 over 5, and that can be written as one whole number 2 over 5, such that 5 times 1 is 5. 5 plus 2 is 7 over what? 5. Okay, so that is what the answer. Okay, let us go over to the number line. Number line is a way of representing whatever you get as your answer in a line. Okay, a line of the form this is 0, we have 1, 2, we have 3, and so on and so forth, and then we have minus 1, minus 2, minus 3, and so on and so forth. Okay, for instance, if we're asked to illustrate the last example, which is a minus 1 whole number 2 over 5 in this table, this is minus 1, is that correct? So we have minus 1 whole number 2 over 5. Let's assume this is where it falls, so write here minus 1 whole number 2 over 5. What do you need to do? You drop what? A line here, and then you have an arrow pointing what? This way. Okay, you have an arrow pointing this way. What determines where your arrow will face is the sign. Remember, here we have that x is greater than or equal to what? Minus 7 over 5. So because it is greater than goes this way. Okay, so that is what your arrow will follow. Assuming it was less than, then this arrow will face this way. For instance, if we have let's go back to the next page. For instance, if we have a problem where x is less than or equal to 8, this is represented this way. This is 0, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, now this is our 8. We have a point like this because what? We are told that x is less than what? 8. Where the arrow stops does not matter. Where the arrow stops does not matter. It can stop at 0, it can be as long as whatever. Okay, so where it stops does not matter, and at this point you say that x is less than or equal to what? 8. Okay, so that is all about the introductory part of linear inequality. Thank you for joining us in today's class. We'll stop here, but before we go, kindly provide the answer to the following questions on the screen. Welcome back. Do well to use the lesson note on the platform for better understanding and information on what we've just done, and feel free to leave your comment on the comment section or your questions. Till we meet again in our next class, stay safe and bye.